Hi everyone, this is Amit K. In this video, we are going to see what is packet mirroring in Google Cloud. So, packet mirroring, in general, packet mirroring is a technique that allow you to capture and copy a network traffic from one or more source and send it to a designated destination for analysis or inspections. So you can say like it's like setting up your surveillance cameras for your network traffic, which will enable you to monitor and analyze the traffic in details, right? So packet mirroring, it clones the traffic of a specified instance in your virtual private network and forward it to the destinations, right? So packet mirroring, captures all the traffic and packet data, including the payloads and JSON. The capture can be configured for both your ingress or maybe the incoming traffic or the outgoing traffic, right? And the mirror happens on your virtual machine instance and not on the network, right? So packet mirroring is useful when you need to monitor and analyze your security status, and it exports all the traffic, not only the traffic between sampling periods. For example, you can use security software that analyze your mirror traffic to detect all the threats and anomalies, right? And packet mirroring is useful. Um, so this is covered. Okay, how does it work? So packet mirroring basically copy your traffic from a mirrored source and send it to the collected destination. So mirror source is the VM that you want to mirror the traffic. Basically, you want to examine the traffic. So all the traffic from the mirrored source, it's sending it to the collected destination. So there are two things: mirrored source and a collector destination. So mirrored source can be a compute engine VM instance that you can select by specifying the subnets, the network tag, or the instance name. So if you specify a subnet, all the existing and future instance in that subnets can be mirrored, right? And you can also specify your mirror source based on the network tags. So if you select the tags, then all the selected source based on the tags can be captured as a mirrored sources. So packet mirroring collects traffic from an instance network interface, right? In the network where the packets mirroring policies apply. So I'll cover this mirroring policy. This is important, right? And the collector destination, you will set up this collector destination is an instance group, and it should be behind the internal load balancer, right? Instance in the instance group that are referred as a collector instance. So a collector destination is always, you will always define it behind the internal load balancer, right? So you can have a multiple VM instance behind the internal load balancer. If the load goes high, then it will automatically spin up the new instance in case you are using the managed instance group. So this is the collector destination in same. This is basically a design. If you want to capture a VM, I mean a mirror source in within the same VPC network. So packet mirroring policy that has all the resources in the same VPC networks. So in this architecture, you can see I have a single project where I have a VPC network, and within that VPC network, this is my VM that I want to capture all the traffic, and I name it mirror VM. And on this is your collector subnet. It could be in your same subnet or on other subnet, but it has to be in the same VPC network. So behind this load balancer, I have the instance group, the collector instance group, and whatever traffic when you mirror when you capture the traffic on this mirror VM, it will be send it to your load balancer, and the load balancer will forward the traffic to your collector VM instance, right? So we will see how we can um, you know um, how we can set up this architecture in our demo. So first create let's just first create a demo. So just a second. So right now I am into my Google Cloud Console. So as per the design, what I'm going to do, and this is my project, uh, 1118, and here I already have a VM instance that I want to mirror the traffic. So this web one is something that is exposed to the internet by this external IP, this public IP. So if you just hit this VM from the public internet, you would be able to access this web server. So I want to analyze this traffic, right? Or whatever traffic that is coming to your web server. I want to analyze this traffic into my collector instance. So this web one becomes your mirror source, and the collector instance has become your analyze or destination source, right? Or destination, right? So how we can do that? So you can see that this collector instance is I have used as used in the instance group. If you just go to the an instance group, I'll show you. this instance. This is an unmanaged instance group, but you can also use as a in managed instance group. So there is one instance is already added. There is nothing in it in this machine. There is nothing nothing is installed except the TCP dump. So TCP dump is the utility that you can use to monitor your traffic, but you can use other paid software or third party software. And if I go to the load balancer, so I need to create a load balancer, right? Just go to the load balancer. As per the design, you can see that this collector instance or designated or destination instance should be behind your internal load balancer. So this internal load balancer is ultimately the endpoint for your mirrored source, mirrored VMs, right? Using the policy. So this packet mirroring policy, I'll show you how we can create this packet mirroring policy. So let's just first create the load balancer. So here I'm going to select a network load balancer. And since this traffic is going to be internal, I'm just selecting the pass through. So I'm going to name it my LB. The reason I have selected is make sure that the mirror VM and this load balancer has to be in the same region. Otherwise, it won't work. So please bear this in mind. So I'm going to select Mumbai. This is my VPC. And for backend, I'm going to select my instance group. And here, the health check, simply create a health check. So it fails because I have nothing running in my instance, but that doesn't impact this demo. So here, just leave it default. I mean, don't select anything in session affinity, otherwise it won't work. And then go to the front end. Here, I just name it FE1 subnets. And right now I'm taking all the port number. Global access, if you want to enable this, you can enable it. Basically, enabling the global access, your internal load balancer will still be regional, but it will have a cross regional access. I mean, you can access from the other region as well, but I don't need this. So this is very important, packet mirroring. So you can see that packet mirroring aims to provide a functionality in the cloud which can mirror a customer regular traffic and fulfill a customer needs for advanced security and application performance monitoring. So you need to select this. If you don't select this, then the, the traffic, it will not be able to capture the traffic. Okay, now you can review this and just create it. All right, so it's going to take some time. Meanwhile, in another tab, I'm just logging to my compute engine. So you can see that I'm already logged into my collector instance. You can this instance, right, which is behind my load balancer, where I have already configured a TCP dump. So, so we have a command. Uh, let me. Okay, so right now I think my load balancer is ready. So now before I log in and show you the traffic, you need to create a policy, right? So go to your VPC network, and here you'll see something packet mirroring, and you just need to select it because we are now going to configure a policy to capture your mirror source with this destination collector. Okay, so how do you do that? You create a policy, right? So just create a policy. I'm going to name it policy policy one, region south one, and here it says mirror source and collector destination are in the same VPC networks, right? So we are doing this demo. Everything is within the same VPC network. So you select the first one, select the VPC one, continue, and here I told you, right, you can select the mirror source based on these three items, like select one or more subnetworks or tags or individual instance, right? If you select this subnet, then all the feature instance or all the instance within that subnet is by default captured as a mirrored source. But right now I will go with the individual instance. So just select this web one because I want to capture the traffic on this instance, so it will become my mirrored source. So this is my mirrored source web one. Continue. What is the collector destination? So the collector destination is showing load balancer, right? So load balance, because my collector is behind the load balancer, so you will select this collector load balancer. Continue. So here you can select a mirror traffic based on all traffic or a filter traffic. So if you want to specify your traffic for specific protocol, you can select your specific protocol like ICMP, TCP, UDP, or other protocols. Or maybe you want to select a specific IP range, you can select it. Or you want to just see specific traffic directions, so you can see allow ingress, egress, or both. So as of now, I just go with all just for this demo. What happened? Okay, make sure that all the fields, what is the issue here? Policy 1 enabled. This is my VPC network. This is my, okay, this is done. Select the, this something. Oh, sorry, I need to just, you know, revert it to the default values. So just click on default. So the policy 1 is going to update it. Meanwhile, I have already logged into um, my collector instance, right? And then there is a command called dump, TCP dump. TCP dump. So TCP dump, you can use this TCP dump command line um, to basically, uh, capture the traffic. So how you can do that? So sudo TCP dump -i. So I is going to be your interface name. Most of the time it's ENS4. If you don't know, then simply write IPA. So this is your network interface card, right? So you need to check this ENS4 -f, and then the host name. And what is the host name? I mean this the mirror VM, source VM, which is a web1 IP is 10.255.88.11. So I want to analyze this source on this source VM, and that's it. I just need to hit it. So right now you can see that the TCP dump is listening on this network card for this IP, right? So let's do one thing. Let's copy the external IP of web1 and try to hit this here. The moment you hit, you will see some. I mean, this collector VM is now going to capture the traffic, which is an ingress traffic. So you can see that this is your VM IP, right? 10.255.80.11, right? So right now you can see that it is capturing all the traffic. So if you just hit this many times, it is going to capture it, right? So this is how you can capture the traffic. Um, you can capture the traffic or mirror the traffic. So even if you want to capture your egress traffic, just log into your web1 and just try to ping google.com. Let's just try it. I'll show you. Okay. So right now I'm logging into my web1. Now try to ping google.com. Now let's see. So you can see that um, this traffic is now going to capture here as well. You see that all the pings are going through, and the traffic is also mirroring here as well. This is my this is the IP of my web1, right? So so instead of making any changes to your source VM, you can replicate the same onto your target or destination or collector instance, and you can analyze the traffic, or you can find so that you can find the threads or any anomalies here, right? So let's just close this web1, and I'm also going to interrupt this TCP dump. So let's see the next use case. So here I have, I have covered this uh, first use case or first architecture, where we everything is in the same VPC network. So we created our web one, which is mirror VM. Then we created our collector instance and internal load balancer. Then we created the policy here, and then we try to find see the traffic is, mirror packets are, sending here to my load balancer, and you can analyze those traffic or packets into by logging into your collector instance, right? So far we are good, right? Now, second architecture, it could be like this. So collector and destination in a peer network. So let's imagine that, like, your packet mirroring policy in a central network paired with the other network that have a mirrored source. So let's say you have a two network across the project, right? This particular project we have already covered here. Now we are adding one more project where we have one more network, and we have a source VM here, but we want to, mirror the packets in the network in the project A. So where we have the collector instance, right? So the traffic will be mirrored and replicated here. So how this is possible? We can create a VPC peering, right? So only the source VM is going to be, targeted in the another project or another VPC network, right? And everything remains same. So let's see this in demo. So let's log into my console, and here I will select. Let's just close this. I select this second project 26526, where I have a VPC network. If you go to my if I go to the VPC network here, I have another VPC. The name is producer VPC, right? And it has two subnets in Mumbai. So this is my first project. And if you see the VPC network pairing, I already set up the VPC pairing between these two. So I have already done this, just to save my time. And here also I have a VM instance, web 2. I named it. Okay, I think I deleted it. So let me just create it again. So I'll name it web 2. I'm going to make it in Mumbai region. So always remember that the region has to be same, because the load balancer is a regional, right? So networking, just select your own network, the producer VPC. This is a network in this project, and I'm also adding this public IP, and I'm also going to add some startup script, because this is my web server, and just create it. Okay, so this is your web 2. If you try to hit this web 2 from the public internet, you'll be able to access it. Take some time. Just wait for some time. Yeah, so you can see that your web server is accessible, but this VM is not in my first project. It is in second project, and there is a peering already happened, right? So now the policy that you are going to create, you'll create a policy here in the project P. So wherever is your mirror VM, which I mean whatever project that your mirror VM has, you'll create the policy over there, not into the collector one, okay, or the destination one. So I'm going to my VPC network again and packet mirroring. And here I'll create a policy. I'll make it policy 2, Mumbai region. And here you will need to select this option: mirrored source and collector destination are in a separate paired VPC network. So my mirrored source VPC network is producer VPC, which is this project, right? And my collector destination network is in the another project. So I will select. Oh, sorry. Okay, the collector destination the VPC network is VPC1, which is in a my first project, right? So I'll select this, continue. Here also I'll just select the individual one, continue. Collector destination is again going to be my load balancer. and here I'm going to see all the traffic. So right now I'm already logged into my collector instance, the same collector instance which is in my VPC1 network. Okay, so the policy 2 has been created. Now just grab the private IP of my web 2 and 192.3, and here just replace with this IP. Right? And now my TCP dump is listening on this for this host, right? So let's do one thing. Let's try to copy this public IP and hit it from your browser, and let's see it started capturing the traffic which is hitting to your web 2. So you can see that, right? This is how you can set up this a collector destination in a peer network. Okay, so all right, so we have covered these collector destination in a peer network. Let's move on to my next architecture where we have a shared VPC model. So I'm not going to cover the demo on the shared VPC, but I'm going to explain how you can set up the same collector and create your policy in a shared VPC model. So here, if you see that you have a shared VPC architecture, the mirror instance for these collector destinations are all in the same shared VPC network, right? So if you know how what is shared VPC, so the shared VPC is basically where we have a VPC network, but it is shared with your service projects, right? So the shared VPC where you will deploy this, I mean, where you deploy the shared VPC, this that project will become your host project, and all other project are become the service project, and those service projects can be attached to your host project. So for IP allocations, all the service project resource as going to allocate their IP address from the shared VPC network. Right, so here you can see that you have a shared VPC network in US Central, and you have two subnets which is shared with your both the service project. And in subnet collector, which is a subnet name, basically you have deployed a load balancer which is in a dedicated service project, and you also have a mirror VM, and you can create you know a mirror VM. I mean a mirror VM here, and you can send the traffic, the mirror traffic to your destinations load balancer, and this destinations load balancer will forward the traffic to the collector instance, right? And the policy that you can also create in the service project only, because I told you wherever you have a source VM or the mirrored source VM, the policy will be created in that project only. Similarly, here also you can create a service project, and you can attach the service project to the host project, and you can create your mirror VM as here as well, right? So if you want to if you want to set up a collector destination in the host project, let's say here as well, you can create your load balancer in the host project, and all this service project is going to have the source VM or the mirror VM, and since these service projects are attached to this host project, so basically the network is allocated from the shared VPC only, and that's why multiple service project can have a mirror VM, can send the mirror traffic to this load balancer, and the policy can be attached, right? Because they are in the same network, right? So this is how you can um, the use the mirror use the packet mirroring. And in nutshell, it is the packet mirroring is a network monitoring technique that capture copies of network traffic and sends them to a designated collector for analysis. So it's like putting a tap on a network cable and to see all the data flowing through it, right? So it captures all the full contents of the packets, including the headers and payloads, and providing a detailed view of the network activity, right? So try to do a demo on the shared VPC. If you know how to set up a shared VPC, then you can use the logic how to set up all this setup in a shared VPC model. So that's it for now. Thank you for watching.